All right, we have it all graphed. Before we get into the proof, I have mentioned to you that everything needs to be done in pen, correct? Including your bubble sheet, except for two things can be done in pencil: constructions and graphs. Here's what I mean by graphs. So pay attention to this because I don't need 30 hands up being like, should I do this in pen? Should I do it in pencil? This can be done in pencil. The work that we're about to do off the graph has to be done in pen. All right, that's what I mean by pencil for graph only. The graph that you just did can be done in pencil. The work that we're just about to do has to be done in pen. All right, so that's what I mean by graphs can be done in pencil, but the work around it in pen. All right, before we get into the proof statement, look right below the given. D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. Before we start anything, we need to find those midpoints. So I guess I'm going to need to know the midpoint formula. Everybody got the formulas to know sheet, right? Look at number 2. We can fill this in right now. Midpoint. And I decided to print these out. I told you I wasn't going to, but I thought the chances were real slim that many of you were going to do it on your own. So that's why I printed out. I'm going to force you to at least write in a few formulas. Midpoint formula. Add your x's, x1 and x2, divide by 2. Add your y's, y1, y2, divide by 2. And there's your midpoint formula. Something we've been using since Unit 1. Not on the formula sheet. Any of these formulas in front of you right now are your responsibility. They're not on the formula sheet. All right, so go ahead right now. You can work in your groups if you want. Check in your groups to make sure everyone's got the same point. I need you to find point D, point E, and point F, and please graph them after you find them using the midpoint formula. D, E, and F. So find the midpoint of all three sides. Make sure you graph them. And when you graph them, you'll definitely know if you got the right point or not, because it should fall in the middle of all three sides. And make sure we check, make sure we all have the same midpoints, they're all graphed correctly. Before we haven't even gotten to the proof statement yet, we're just setting this up. Just setting this up. sure it's plus in between. All right, I'm going to move on, everybody. I'm going to move on so that we needed those 3 points to set up the first proof statement, which is ADEF. Let's show that's a parallelogram. If you haven't connected those yet, let's connect them so we can see this quadrilateral. We need to prove a parallelogram. So ADEF. All right, we're going to prove this is a parallelogram. So we're going to make somebody's going to make a class decision for us, but on the Regents exam, you can do whatever you're comfortable with. There's a couple ways we could show this is a parallelogram. We could show opposite sides are parallel. What formula would I need for that? Slope, yep. I could show, if I don't like that, I could show both pair are congruent. And what formula would I need for that? Distance. Or if you're really nuts, I just want to review this too. There is a special case where one set of opposite sides are both congruent and parallel. We called it the special case. That would need slope and distance. So somebody's going to make a class decision for us right now. All right. Again, the day of the Regents, if you really like slope and comfortable with it, then do parallel. If you really like distance, do the congruent, opposite sides congruent. But I want to do it the same exact way in here for now. Well, big decision here, Finley. What do you want to do? Distance. All right. I'm fine with that. All right. We can do distance. And actually, that's a great call, and everyone will see why at the end of this proof when we go to the next part. All right. This is a proof. I know it's not 2 columns, statement reasons. We haven't reviewed those yet, but it still needs to be organized with steps. So here we go. Step 1. And please make this organized. I don't know if I've mentioned it in here or not. Tell me if I did or not. I'm not allowed to grade these. Your Regents exam, I am not allowed to grade it. I guess the reason being that I would show favoritism to your own students, even though, let's face it, most of you I would show 0 favoritism to. All right, but that's why. All right, I'm not allowed to grade it. So you have to be as neat as possible because other math teachers are going to look at it. And if it looks like you've done this with your pen in your mouth and did all this work, and it just looks like we went over to Eagle Elementary kindergartens and that's what it looks like, they're probably not going to take it too seriously. So please have it organized and write as neat as possible because I am not looking at it. All right, I don't even see them at all, actually. Okay, so please remember that. Because just coming from me personally, I pick up an exam to grade and it's all over the place and not even close to neat and they didn't make any effort. I'm not taking it seriously. And probably the teachers won't take it seriously with your exam if it's like that. But I don't have many worries in this class with that. So just try to make it neat and organized. So Finley's going to do opposite sides congruent using the distance formula. All right, here we go. Distance formula. You can write this right in number 1 now as well on your formulas to know. Distance formula, big square root, as we remember, underneath the square root, we have 2 parentheses. In the first one, x2 minus x1, all squared. There's a plus sign separating those parentheses. In the other parenthesis, we have y2 minus y1, all squared. So we go back, and I'll tell you what, I know Finley probably didn't realize this, but she did you real solid here. I only actually have to do distance formula on 2 of the sides. Anybody know why? I don't need distance formula on I need it on 1 pair, but not the other pair. I'll do distance formula to find the length of EF and DA, but I don't need it on AF and DE. Why not? I hope so, right? Look. 1, 2, 3, I can count that distance. All right, so you don't need it on any horizontal or vertical line. So right now, all right underneath your distance formula, AD, show me the distance of AD, show me the distance of EF, and also the other 2 opposite sides, which you can just count when you get to them, AF and DE. So go ahead, work with each other if you want, compare your answers if you'd like as well. But I'll give you guys minutes here to find those distances. Should be getting the square root of 41, I hope, out of AD and EF. So what is that, 6? Square root of 41 and then 6. Leave it square root of 41. All right, I don't need your 6.4 and change. Again, this could have been different for you if I called on somebody other than Finley and they said, let's do opposite sides parallel. You'd see a whole bunch of slope formulas here instead. Next step when you're doing a coordinate proof. The second step should always be, what did I just learn by doing the formulas in step 1? All right, what did you just show me? What did you just show me about your diagram? You didn't show me it was a parallelogram yet. Right, you did not show. What did you show me by doing these distances? What did you show me there? Where are we going here? Alyssa, what did we just show? Okay, AD congruent to EF and AF is congruent to DE. That's what I just showed, and you always have to have a because here. Just can't write it down without backing it up. Why are they congruent? Use your work now. Use your work. Finley, back to you. Your proof. Done. That's all I need. That's all I need because distances are equal. If you did slopes instead of congruent, I would have parallel here instead, showing the lines are parallel because slopes are equal. All right, good. I think we got a parallelogram now, don't we? What do we have? ADEF is a. Also, I know I'm not allowed to correct your test, but you are allowed to do any shorthand that I've done all year long, like parallelogram. You can. That's fine. All right, you're not going to get taken off. Teachers will know what you're talking about. All right, so you can do any. If you start making up your own hieroglyphics, I can't help you there. Okay, so any shorthand I've done, I've done what? Right angle, definition of, all that stuff you can do. Right, all that stuff. All right, why is it a parallelogram? What's your because here? How do we know it's a parallelogram? Shoom, Zoli, why is it a parallelogram? Opposite sides are congruent. Good. Notice we're all keeping this organized, right? All keeping it organized. And there's a second part, and this is why you should be thanking Finley there. It's because of the second part. Show it's not a rhombus. What's the big property of a rhombus? And if you don't know, you got a packet that's got all your properties in it, a flow chart. What is the big property of a rhombus? All sides congruent. And what did we just do here? We did it already. We don't need to repeat it. If we did using slope instead, my next step would be showing at least two sides are not equal using the distance formula. Okay, but work's already done. Work's already done. ADEF is a rhombus, or is not a rhombus, sorry. Is not a rhombus. And what's your because here now? ADEF is not a rhombus because, why? Shoom. Jared, why not there, boss? Yeah, perfect. All sides are not equal. Again, if you did slope, you can't write that until you show me two sides are not equal using distance. So maybe looking over the entire proof first and then saying, well, might be a good idea to do distance because I'm going to need it to show it's not a rhombus, but that's up to you. All right, we good here? Everything's organized. All right, last one we're going to do here. We only have time for two. Before you graph it, heads up, before you graph it, point K has a 13 on the x-axis. So you might not want to do it right down the middle like you usually do. You need 13 on the x-axis to graph. So just a heads up so you don't get frustrated and have to erase it all. Got the graphs looking here, almost done there. Getting your 13, comma 4 on there. Okay. Also a two-part proof. Also a two-parter. Part 1, prove it's a trapezoid. Part 2, it's not an isosceles trapezoid. Okay, so let's go to part 1. Prove it's a trapezoid. Guys, there's only one property of a trapezoid. That's it. One property of a trapezoid. And that is one pair of opposite sides are parallel. That's it. That's the only property of a trapezoid. So that's what I need to show. And I think by graphing it, we can tell that we're going to have to show ML and KJ are parallel. All right, what formula would I need now? Slopes. Yep, look at that. Number 3 on your sheet. Formula number 3 you got to know. All right, slopes. 2 versions I'll give you. 2 versions. One is the traditional one, which is you change in y on top, y2 minus y1, over your x's, change in your x's, x2 minus x1. Personally, I very rarely use this one because I'm afraid I'm going to make a mistake subtracting or maybe that double negative stuff that always happens. So instead, what I love, especially when something's graph for me and I know I can count, I've been doing it my whole life, I like to use rise over run. That's my go-to for slope. Anybody remember the letter we usually use for slope? We've gone over it with the equations of lines. M, right? Yep. So you're going to find the slope of KJ using one of these formulas, right? One of the bases, and hopefully it comes out to be the same slope as, what's that other one? ML? There you go. So you guys decide how you want to find those slopes, and hopefully they're equal. They should be equal because we're trying to prove it a trapezoid. It's the only property of a trapezoid, one pair of opposite sides. I know they come out to be different fractions, but they both reduce down to 1/2, I hope. What did it come out to be? 6/12. I know one of them. And 4/8. Yeah, 6/12 and 4/8. All right, perfect. Step 2, what'd you learn? It's not a trapezoid, and you didn't learn that yet. What did you just learn by the work above? There's a reason you did it that way. What did we just learn from the work above there? Cormac?
ML parallel to JK.
Seriously, yeah. ML parallel to, yep, never mind. KJ. Why, Cormac?
Because their slopes are.
Yep. All right, now it's a trapezoid. That's all I needed. What's this bad boy called? JMLK is a trapezoid. Because now be careful when you write why it's a trapezoid. I might have a couple people write because opposite sides are parallel. No, not opposite sides. That's a parallelogram. All right, because one pair. Let's make sure it's one pair. You didn't do both pair. One pair of opposite sides parallel. Any questions what we've done so far? Because there is a part 2, which is now prove it's not an isosceles trapezoid. All right, we have the parallel sides. What would make it isosceles now? If we did what? What would make this trapezoid? It's a trapezoid now. What else would make it an isosceles trapezoid? Tell me where to put markings, anything. What would make this isosceles now? I know it's a trapezoid, Stephanie. What makes it isosceles? What do you think? Think about the word isosceles. I know we usually do a triangle with it, but it still kind of applies here. What's isosceles usually mean to you? Like an isosceles triangle, what do you know about it? Yeah, 2 sides are equal. So what do you think of a trapezoid? I got these 2 sides parallel. The other 2 sides have to be congruent. That would be an isosceles trapezoid. Those are called the legs. All right, the bases are parallel. These are the legs. So if we're going to show it's not an isosceles trapezoid, show MJ and KL are not congruent. What formula do I need? Okay, let's go. Show the distance of those legs are not the same. So I'm going to show MJ. You guys do the distance for that bad boy and the distance for LK. And we hope they're correct, but they're different. Three radical 5, square root of 65, hopefully. Or you can leave it square root of 45. That's fine too, but 3 radical 5 would reduce it down to. Hopefully we're doing the right coordinates, right? Subtracting the right coordinates for the distance formula. All right, I'm going to finish it here. I can help you out if you didn't get those distances. All right, the legs didn't come out to be equal, so guess what? MLKJ is not an isosceles trapezoid because you can say the other 2 sides are not congruent, the non-parallel sides are congruent. If you want to use the official term for it, because the legs, those are called the legs, the congruent sides, or should be congruent. The legs are not congruent. But again, you can say the non-parallel sides, the other 2 opposite sides are not congruent. Anything that gets the point across. And you see what the assignment is from each of the exams, the coordinate proof from each of the last 3 exams I printed out for you. Tomorrow, when you walk in, it's straight business. I'm not going to say anything. You come in here and you get ready to work. Whatever Regents exam you need to work on that you haven't tried yet, examples you haven't tried, it's all work tomorrow to get ready for Thursday. All right, and I'm going to be all over you guys to make sure you're focused and staying on task.